should be online again. Yes, I am. Still part 3. So I don't know how Twitch works, if it's still same video or the next video. Don't care. So what we need to do is now, do we want to check the output, or do we use the multimeter just to check the output? It would be nice to have the oscilloscope checking the output. So let's disconnect that. Up, up, up. Let's switch the camera. Need to fix this a bit better. So the oscilloscope will be connected to the mains. For that, I will just disconnect mains in the beginning. Up. Let's set the channel accordingly. AC. Up. Up. 100 volts per division. We only want, I think one would be enough. One part will be on live, and we will put the clip on neutral. And if we connect it, we see the AC waveform. But this is the output. Why is there AC outputs right now? Well, there's no load, so I think it doesn't count. There must be a load before the triac is really able to work. So let's put a load. And yes, we can clearly see the triac working. That's nice. So our triac works. Now, the lamp is still flickering. Do we see, is the flickering because of this jitter? Maybe. It's really clearly visible on the lamp. I don't think on the motor it's really important, but we will need somehow to clean it up so the zero crossing isn't really clean. How would I clean this up? I can have a moving average, so we could do it in software. We could try it on the falling edge instead of the rising edge, because we have a rising and a falling edge. Can we see the jitter? That would be nice to see. So here there should be something horizontal, rise time info, pulse, duty cycle, duty. Does the oscilloscope show the jitter? Hey, not so fast. Whenever I try delay 1, duty cycle, duty width, fall time, rise time. Okay. So the oscilloscope is not able to show me the jitter. Not a shame. Oh, I didn't find it, at least in the measurements. Up. Switch. You can also see in the measurements with period, frequency, rise time, fall time, with positive width, negative width, duty cycle, delay between 1 and 2, 1 and 1, phase delay, duty cycle, minus, phase 1. No, it doesn't show the jitter. Let's try with the code on the falling edge instead of the rising edge. It's not ideal because the rising edge would be better if we want 100%, but we don't care about 100% because we will never power the motor with 100%. Far too powerful. So zero crossing, interrupt service routing on falling. It now flashes the code. So by default it's switched off. This is good. Maybe the timer has just... No, I don't think so. I don't hope so. We didn't have any jitter on the... Oh, it seems to be more stable. Yeah, so we'll use the falling edge. The issue with the falling edge is that it's not immediately, it's after the zero crossing, not before the zero crossing, so we wouldn't be able to really effectively switch on 100%. We don't really care about this. It makes this a lot more stable. The output a lot more stable, and we will have, I expect something like 10%, maximum 10%. I have to try it this evening where I'm there. But for now, the thing works. All the electronic works. The tachometer is not here, and I cannot test it. We had the tachometer is not there, and the calculation is not here yet. I have set up the pin for the tachometer input, but because I don't have the tachometer, I didn't test it. But I've tested it the last time. I know how it works. We just need the circuit with it. So this works. This is good. I like that somehow the triac, the output, when there's no load, you see the complete AC output, AC wave output. So let's switch everything off, disconnect up, disconnect the oscilloscope, switch the camera. I need to change this so it holds better. And I know how to do that, but we will do it next time. Every time I do a stream, there is a new setup. This time, I don't know if you see it, but the camera which is filming the oscilloscope is now the DSLR, while the camera which is filming the bench is now the camcorder. And I use the camcorder because the camcorder all the time tries to make focus continuously, while on the DSLR, I needed to click on the button so it makes the focus. So still something new. Next time I will fix this matrix switcher, HDMI switcher. But for now we disconnect. Well, we have everything we need to make the case, to make the device and to put it in the case. The breadboard is kind of finished. What we didn't test is the input of the tachometer. I already have a tachometer circuit, which is work, so I'm confident enough that it will work. So let's disconnect everything. And it starts making it on the board. Let's disconnect power. It's the most important part. Switch off the isolation switch, the isolation transformer. Yep, it is switched off. Make a bit of space, so disconnect the lamp. Can leave it here for now. I can test it, so we can test it afterwards. But I would like a bit some space for soldering. We can disconnect all of these things. So this cable goes here, female, male. This USB switch goes away. Up all the jumper wires. Let's do it this way. Jumper wires. Up all the crocodile clips. Gone. We don't need you anymore. Up. Let's make the bench a bit cleaner. If you're wondering, and if you're watching the videos, the recordings on the YouTube channel, QView stream, I also disabled the comments there, simply because for me streaming is fire and forget. So if you want to say something, you will be there for the stream and talk in the chat, even if it's just one of the previous stream, but I kind of don't have the patience or the muse to read the comments after I did the stream. This is why comments are also disabled there. Tape. That's the USB. Oscilloscope. We can. Let's just keep the oscilloscope on. We might use it afterwards. Tape. Now we'll remove this. Oh, there's still some tape. And I'll put it on the second table, on the to clean table, which you cannot see, but there's even more stuff. This tape is holding better than expected. Oh, the sun is coming out. Not for long. A couple of hours, it's dark again. Yep. I think I received a message. Nothing important. Yep. Crocodile clip 1. That's USB power supply. Yep. There's plenty of dust on this bench. Put it on the ground. The parts. Everything on the ground, it's easier for the vacuum cleaner. Oh. That's actually this USB cable anymore. That's a USB cable for the DSLR. Up. Yes, this is also kind of a rant. On this DSLR, it's a Panasonic one, but I think it's most of them have the same issues. You don't have a normal connector. It's not micro USB. It's some kind of weird USB. So you need some kind of weird connector. So you need a dedicated USB cable. Why not offer micro USB? Maybe they do now. I hope they do now. But previously they kind of combined micro USB or the USB with the audio video signal. And this is why, because they have more pins than micro USB allows. They have this kind of special cable. But they put another port. And the other important thing, which I hate about DSLRs, is you cannot charge over USB. Why can't you charge over USB? Every phone charges over USB. The charging circuit is really small nowadays. So putting a small charging circuit for you charging over USB doesn't cost a lot of money and a lot of space into the DSLR. I think it's just because they want to sell you more batteries or more chargers, external chargers. I mean, sure, external chargers would charge the battery faster, and the battery probably can cope with fasting, so it's better. But I didn't say replace it, I just adds to it. So whenever you have the camera, you are on holidays and there is nothing, you forgot your charger for your special kind of stupid battery, then you can still charge it with your micro USB. Like you charge everything with micro USB. So instead, this DSLR has I salvaged a battery and I put a circuit inside which simulates the battery. This is how I can have power that enables the DSLR always on without showing on the battery all the time. So here are all the let's collect all the components and try to put everything into space. So, and change the connector and so on, because now we are really building a case. We for now are sure that the input will be either it's on the side here or it's on the top. I think it looks better on the top, and the top is large enough to accept it, and there's already a hole, which, because I already used this case for something else, or it was used for something else, I don't know. So we need all these components. That's almost all of them. What we also need is this bridge rectifier and optocoupler. I have plenty of them. Light barrier? No, not light barrier. Just need to find the right box. Power protection. Oh, E-switch. Yeah, here it is. E-switch and optocoupler. Up. It should be in this box. Yes, here we have optocouplers. PCF 817. Really standard optocouplers. But I always forget which is the anode, the cathode, the emitter, and the collector. But for that I know I have the data sheet. So we will check the data sheet. So we have an optocoupler. We use on the transistor side, we use the pull-up resistor of this board, embedded in the microcontroller. So we don't need an external pull-up resistor. What we do need though is on the other side a resistor for the LED. So we have 10 volt spikes. The LED should use something like 1.8 volts, but I don't know how much current it is able to provide. So what we will do, instead of having a fixed resistor, which we could have actually, yes, I could have a fixed resistor, but instead of the fixed resistor we can use a trim pot also. I have plenty of them with different values. This is 1K. Yeah, I'll use one of these. $1K would be maximum. I think 1K is good enough. I could measure. There's something in between. Everything is higher than 1K. Ah, here, 20K. Oh, 20K, 2K. And it's... I mixed the devices. This should be actually... Why do you have vertical things inside here? The horizontal one should be here, and the vertical should be on the other side. Okay, I've mixed. I have two trim pot cases. One should be for vertical mount, and not the other one for the horizontal mount. But somehow, the one which I have here, which I'm using, the 1K, so 102 should be 1K, horizontally mounted instead of vertically. Meh, not important. Up, trim pots. Let's check with the multimeter if it's really 1K. Yes, it's 1K. 1K should be fine for the LED. I think it's an infrared LED. Infrared LED will use even less power, something like 1.6, 1.2 volts. I don't know. But the 1K on the input here should limit the current from the tachometer, and I don't think it will break anything because it's really short pulses. And with pulses, these are capable, the LEDs inside are probably capable of handling 100 milliamps, something like that. We could look at the datasheet, but we will never have 100 milliamps output from the tachometer. Tachometer. I say multimeter. Why shouldn't I say tachometer or tachometer? I don't know. The one which counts the cycles, the rotation. So now we need to place everything in the box. We will have the input here with spade connectors, or we can solder them. The advantage of having spade connectors is we can remove this thing. I think we will solder them correctly on the thing because we don't have a lot of space for huge cables. And it will either be on the top, ideally on this side. So I always try to have the output on the other side than the input. So ideally it would be here. But we don't have enough connections here. So the output will probably be on the top or the bottom. That doesn't make a difference. And this way we have enough space for the board and 3 other inputs. The 3, even more. We have 2 inputs for the tachometer and 3 outputs for the power. Fits nicely in between here. So there will be the power, there will be this thing, no need for cooling. We'll probably put it somewhere here. This will be the AC input. The AC input should be on the other side directly, so we will have our device furthest away from the AC in case anything happens. Because this device is, I want to check to have the device visible, so I don't want it to flip it here. Means we will do it this way. Put it on this side. Why doesn't it work anymore? I want to have this whole AC. Okay. This side. This here. This probably this way. Not completely here because I need the connectors. And with the connectors I still did decide what type of connectors I want. Have the output something like this. Yep. Now connectors, let's check again what we have. We will have spade connectors, as you see on the pictures from the motor. We have spade connectors on the side, so it's kind of loose wires. That would be, can I use this? No. I will not use this because they have exposed pins and the AC will be on the exposed pins, and somehow just putting some power, being able to touch with the screwdriver inside could short 2 pins, create an issue. Although they are nice, it would be even nicer if they would be shorted inside. They're only shorted outside. Something like this. That would be ideal, because when you have it here, it's hard. When you have the power going here, it's hard to poke your fingers inside, and you can have the cables connected. But on the other side, you have here, which is not ideal, the exposed wires. things here. You can also touch it directly, but it could happen because of a loose screw that you're touching live. We don't want that. We can add trick tube on top of it. Good. Do I have other connectors which could be useful? I have an idea. It's not a bad idea. Instead of using these kinds of connectors, what we could, so having the connectors exposed, and then I don't even need, because if I want to flash it, I can open the box. That could be nice. Instead of having these kind of connectors, what we can have is just wires dangling out, and on the wires we can then connect whatever we want, and I'll show you what they mean, because the connectors are nice and I don't use them often enough. I just need to find them again. Cable plus connector one time. I think I've put it in here. Is it here? No, they're not here. So these are really board-to-board connectors. It's not IDC cables. Here, power cables. Oh, I even forgot here. This box here, 2 to 4 power cables plus connectors. Yeah. I think it is inside here. So here we have the connectors, sort of Wago clips. What I wanted to have is, so these are normally, these are really fast clips, Wago fast clips, perfect for prototyping, how low power, even not for prototyping, you can leave them here, they're really reliable, instead of having these kinds of spring terminals. Well, they are also spring terminals, but I find them a lot more robust. These are connectors for batteries from the RC world. But what I wanted are these connectors here. 2 and 3, perfect. I thought I had more of them, but I have enough for the project. These are automotive connectors. I don't remember why I have them, but you have this kind of crimping cables plus silicone rubber sleeves, and they are water protected, which is ideal for the site we will go into, or for where we'll put them into. So we could almost make this completely sealed. This will be mounted here, and we can have a cable gland going out. We could make a smaller box. I'll have smaller boxes. We'll test with smaller boxes. We can have a cable gland on the outside to have the cable going out. So how this works, you have to put the pins in. So these are the pins inside. You have to put them, and then you clip it this. So this is also a silicone gasket, kind of a rubber. When you connect it this way, it is water protected, and because there is a notch, you cannot put it on the other side. The connections are large, you can put large cables, so for power it's ideal. I think this is what we'll use. There will be one connection for the power, live neutral earth, up, and there will be a connection of 2 for the tachometer. It's really an overkill for just a tachometer to have this kind of connector, but it looks nice and it will hold well, because the tachometer will be the most important part. Well, not most important part, but it's an important part to figure out if it works or not. So here, yeah. Here will be the connection to the tachometer, and then we will have cable It should go this way. There's a thing inside which probably doesn't belong inside, does it? Oh, it does belong inside. Okay, back. This way. Up. And so we always have the power on the shrouded parts. This will be the shrouded parts, and these are a bit less shrouded, so you have access to the pins. So this will be on the motor side because the motor is not powered. So even if you touch with the fingers or with a piece of metal, you won't get electrocuted. Wow, the sun is really shining. The contrast is really high now on the camera, even with my backlight on. The shadows are strong. So yeah, I think we will use this. So we will have just cables going out from here or the other side like this, and you will have two connections. And with that, we spare a lot of space. So what we could do, instead of having this large case, we could even try to have a smaller case, which already has holes. Why not? Why not? Why not? And this will also, I thought about something like this. So it is a bit smaller, and we wouldn't be able to fit here, but we will have two holes. One hole would be for the power input, so we just can put a plug, really a socket plug, so we don't need a cable to connect here. And on the other side we have the power, so the cable output. And here we have the clamps, and this will be complete waterproof. I think that's a good solution. I have two of these boxes, so we could use one. Does everything fit inside? So yeah, no, although it's a shame that there would be no switch anymore. The switch would be, yeah. I like the idea of having a switch on the board to switch everything on and off. On the other side, if you really want to not have any power, you can, yeah, the one which would be able to go up and switch on and off will probably also be able to just unplug it whenever he doesn't need any power. And we just need the firmware to be good enough that when there's no data, after some timeout, for example after 10 seconds, if there is no data on the DMX channel, then it will shut down the motor, and by default it would shut down the motor. So do everything we can so it shuts down everything. And we will have a fuse, so if we draw too much power, it makes poof. Yeah, because I don't expect anyone which is able to switch on and off this thing to be able to not just unplug it. So we will use this case. See how often we change cases? But I'm missing screws. Here's the gasket. Oh, there are only 2 screws? No, 4 screws. Here are the 4 screws. Ah, yes. IP66 waterproof case. Here we have the silicone, or some kind of rubber, I think it is silicone, to put inside here, so we can make it waterproof. And what's the nice side with this case is we can see from top what's inside. And with electronic, it's always nice to see what is inside your electronics. Tuck, 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 tuck. It's a bit too long. Let's cut it the right size. Can still compress a bit. Oh, it's still too long. I try to compress it. Yeah. This way form a better gasket. don't know why there's a kind of marker here. Up, 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 up. That's the inside. It will have input and output things. Yeah. These are also IP68 rated. You can probably see here IP68. And what you can see is there's some kind of rubber here. So when you put the cable, you just press on here and it presses on the cable, and this makes it watertight. And you can have several sizes. Here it's M12. That's the thickness. But you can also have larger ones like these ones. I think M12 is perfect for our need. Once we have the cables going inside, I have plenty of cables. It's not an issue. Up. Oh, here. And here we also have some silicone. Probably, yeah, exactly. If you put it here. Can we unscrew here? No, that's fixed. There's not a lot of space though. M12 up. This is a nice project box for waterproofing and high power electronics. The board fits in nicely. Well, good enough. It's not perfect. There are holes here. Either we can use the standoffs again on this board actually. I could almost mount everything on, no. Let's put it on a perf board so we can make the connections easily. Since this will not be flashed all the time, what I could do is simply have it inside here and then take it away once I need to flash it. Do we have also the serial connections? Because here there's a micro USB, but if I have it inside, I don't have access to a micro USB anymore. It would be nice to have a plug on top to connect to the serial, and then here, RxTX. On this side of the board we have RxTX. These are the same serial output as this one. So what we could have is just a pin header, so I can come with a I can join here with just a serial cable, plug the serial cable and flash it without having it connected to USB and without removing it from the device, from the case. So everything holds tightly. Or we can have, yeah, we can have all the connections we want here. 3 volts, oh no, voltage in, but we can go from below. Up. Yeah, I think I'll use this case. There will be, this will be somewhere here. Well, there's not too much space though, but we'll manage to put everything inside. Can it stand? No. We still need to have some kind of either a cable, but the problem with the cable, it could get disconnected, or a header going there. We don't want this heatsink to be above the antenna. Where is the power brick? Here's the power brick, so there will be the AC inputs. Okay, I'll bend the pins so it fits on this breadboard. Okay, it's not perfectly fitting, but so now fits on a 100mm base raster. Oof, not a lot of space. We'll make it fit, but it is tight. So yep, still no one in the chats. At least I don't get distracted. Would be nice to use the hold of the board to fix this board. I don't think this will happen. And yeah, we don't have enough space to have the pins in here. So what we will do is just desolder the pins, have wires directly on the board, desolder the pins, have the wires going directly here instead of having a connector. And the heatsink will be fixed inside, probably using hot glue. Hot glue is probably not too much of a good idea because the heatsink will get warm and the hot glue might melt, so we will use something a bit more robust than hot glue. But we don't have the choice for the pins. It's too crowded inside here to have further pins. And yeah, I still need the LED. Oh, that's nice also. Because the box, although I had the LED fine, I just need a higher resistor. I can switch off the LEDs if I want. So the advantage of this case is that I have an LED. This is a clear case, clear top, so I can see the LED inside. Oh, there's plenty of space on top actually. Plenty of space on top. So we still need some space for the. This is isolated? No, I don't know. I don't know if on the PT the heatsink is completely isolated. So if this is it's any potential from live neutral, or if it's just really a heatsink and it's completely isolated. I think it is. I hope it is. I would expect it is though. We need just optocoupler, which we have here. We have the resistor, and we will put it. What you cannot see is here there's some kind of space. So when we add it here on the bottom, we still have a bit of space on this side to put our devices. Okay. Shall we try it? I need a full bridge rectifier. Oh, this is in voltage regulator diodes. Probably in this box. Yeah, other box, voltage regulator and diodes. And I have huge full bridge rectifiers. Something like half bridge rectifier would even be. Would a half bridge rectifier be okay? Let's use a silent component. So I have huge full bridge rectifiers like this. Half bridge would actually also be okay. Yeah, half bridge would be okay. Just a diode. Because the update of tachometer would not be as often, but it would take less space than a full bridge rectifier. Let me check if I have small full bridge rectifiers. The full bridge rectifier would allow us to have 2 pulses per revolution, or I don't know. But I think we don't need to be that precise. The advantage of having a diode is that it doesn't take a lot of space. This is not a full bridge. This is, what is this? Good question. No idea. BYW29. With just 2 pins. It's probably a diode. A huge diode. This is a voltage regulator. I don't have that many voltage rectifiers though. Yeah, I have these ones. These are too large. This will not fit inside. Yeah, I think we will just use a diode. No full bridge rectification. We only want to count tachometer pulses. Half bridge is fine, and half bridge can be done with one LED. LED. So why this? So why do you want to add bridge rectifier on LED before the optocoupler? So on the optocoupler, the tachometer would power the LED inside the optocoupler, the infrared LED. The problem with the infrared LED is that an LED, you could think it's a diode, you don't need to put an other diode on top because it only allows current in one way. The problem with LED is that they have a very low voltage breakdown or reverse voltage protection, meaning that this one I think has a 6 volt reverse voltage diode or reverse voltage, I don't know what it's called exactly. So above 6 volts reverse voltage, the diode will break. That's in the absolute maximum rating. And we have 10 volt peaks. So we want to protect against this. So we don't want reverse voltages on the diode. This is why we use, on the LED, this is why we use a normal diode, power protection diode, or just a normal diode, which is a lot more robust. I have plenty of diodes. I just need to find them. Power, voltage regulator, fuse. No, diode is not inside here. Oh. I have super large diodes, which we've seen in the power protection in the box, which I just had with the voltage regulators. Where was the box? Moved it again. And the other one with the voltage, here. In this box, I had huge diodes with kiloamps, probably. No kiloamps, but with really large capacity. We don't need something that huge. We need just a normal. So these are. So this is my diode LED box, but these are parts which are really meant for batch protection. It's not anything which I've salvaged from devices. These are things I buy in standard cases. Most of the time I use them for my projects. And we will use something like this. General purpose diode 1N4007. You see it has a voltage drop of 1.1 volt at 1 ampere. We won't drop 1 ampere, so it will have a lower voltage drop. But that's not the lower voltage drop. Isn't the high voltage drop compared to Schottky diodes is not too much of a problem because we have plenty of margin. What else? This is Schottky barrier. See, Schottky diodes have a lower voltage drop. This one has only 600 millivolts, 500 millivolts at 2 amps. But the problem is it doesn't protect as well from the others. This has a reverse or forward voltage, or maximum forward voltage or maximum reverse voltage of 40 volts, while the general purpose diode has 1 kilovolt of protection. So it's what we want. Ideally I would test it, but I really don't have the tachometer here and I don't have any AC motor which I can test it on. Here, one diode. Up. Voltage diode box. Up. Now I need a data sheet for this optocoupler, I think pin 1 is always the collector, pin 2 the emitter. I never remember. So, data sheets, optocoupler. You don't need this anymore. You need, which screen is that? 3. Yeah. PC 817, that's the optocoupler. Oh, I did the wrong way around. 1 is actually the anode. So the anode is on this side. Can even put it a bit closer to the board. I have space. This way. Anode. What pin 1 is anode, pin 2 is cathode. We will add the LED. The diode. So we have no reverse voltage coming here, being able to destroy our diode, our LED inside the package. It's this way, right? Yes, it's this way. And we will have this thing in the inputs, thing being the voltage, no, the voltage regulator, potentiometer, because I don't know how much current it is able to cope, it is able to put in. So this would limit the current for the LED inside. You always need some kind of protection for the LED inside, for the LEDs. And if we do it correctly, could even save some space. Is it? Do we have enough space or not? Yes, there's enough space to have it this way. That's the almost the whole circuit. There will be the input for the tachometer. We can even have something so I can unplug and replug it nicely. Or we can solder it. I'll probably solder it so it's fixed and correctly done. Then we'll have something here. This will be here. I want to check if the heatsink is connected to anything. BTA 16, I'm sure I still have the data sheet from yesterday. Just need to find it. BTA 16. BTA 16. Oh. Insulated and uninsulated package outline. Oh, damn it. So it always depends if it's insulated and not insulated. Okay, so they're both versions. Insulated tab. Insulated tab BTA series. So all BTA series. So the let me show you on. So this you've seen pin 1 is the anode. Don't need this anymore, but you need the BTA. BTA, I think it's 3. Yeah. Here, insulated tab for the BTA series. We have a BTA 16. and we don't have one of the others, so our tab is insulated. So even if it contacts anything, there's no problem. We don't need any guard space or some fixing. We just need a way though for it to not move. It would be nice to have. Oh, this thing warms up. It would be nice to use these pins to plug on the board. We do have a lot of height. Do we have enough height? Oh yes, we do have plenty of height. It's not holding inside. But it is. Oh. Yes. The board is high enough that we can put it upside. We don't need to put it on the side here. This way, we can directly plug it on top. Can we? Is there enough space to do it like this? No. These either I have to make bigger holes, and I think that's what I will do. I'll make bigger holes in the board so I can put these things. Yeah. I think that's how I'll mount it. Whoop. One more. Yeah. I'll mount it this way, and at least we do have now enough space for a full bridge rectifier, but too late. Tachometer with half bridge would be fine enough. I don't need really precise measurements for the speed. This way, this will be the complete board. We just need to solder everything, make holes for the rest. And how will I fix the board inside? There I can really use hot glue. Because can I use the screws which are here? No, I have absolutely no access to the screws. To these screws, I have no access to them. I could make these holes bigger, so we can put spacers like this. Then it stands. Let's check if they're small enough. Up. Problem with making the holes bigger is they're already very small. It needs 3mm. I think if I put 3mm, this thing will break, and I cannot create new holes, for example, on the bottom because the spacer is higher. Oh, and also the spacer would collide with the pins of the board. But I want to fix it somehow. So I could have... I think I will put glue. Once inside, I'll just use glue. The coupler is gone also. Glue is not very elegant. We can't use the holes. what if I rearrange so I can use the holes? Because we have more space since we put this high. Could use 4 holes and put everything in a rearranged way so we have access to the 4 holes. That would be nice if this would work. Does this fit here? Nah, doesn't fit enough. The screws wouldn't be able to go inside here. Let's try with other boards. This board is too large, but we can cut the corners. That's not an issue. Even a bit more than the corners. Doesn't fit. We have to cut the complete side. But it allows us to put the device really on the edge. And where we have access to the thing. Oh, that looks nice, doesn't it? Let's put it on this side. Up. Not a lot of space for the cable going in and out, but I think it's doable. Where's the thing? Then this thing on top here. And then we will have access to the 4 holes. The 4 holes will allow us, I don't know the dimensions, but we'll just bunch things. And the 4 holes will allow us to really fix the board on this thing, instead of having to glue this device. The problem with this is that on the edge I have these pins, or these things which don't allow me this. They are not holes all the way to the end, so it doesn't allow me to put the device on the edge. And since I don't use the other ones very often, I can use this one since I will cut it either way. Duck. Does it fit? This would be, it's not completely centered. Oh, QC passed. I also have these stickers, which I used for things I built before I give them to the clients. And this allows me to know that I tested it and it worked at least once. Yep, so I need to cut it. Need to cut complete side, probably this side. Then I can mark the holes for the screws. Let's do that. Let's get the power tools out. Well, power tools. Not sure if you can call this a power tool, but for making holes and for screwing things, it does the job. And I use, this is a metal cutter. This is what I use to cut PCBs. Works nice. So, is it enough? Yes. should be enough to just cut this tab. And you see it really goes. This is 1.6 millimeter board, just the standard height, and it really is easy to cut through it. So to cut boards, the problem is you somehow bend the board. You can see the effect here. You bend the board when you cut it, so it's not really perfect, but for most tasks it's good enough. Else I need to scorch them using a cutter and then put force on it to break it where the scorch is. Up. That's one side. Let's cut the corners. How much do we need to cut from the corner? Not a lot. I'll just eyeball it. 1, 2, 3, 4. Now it fits. I could cut less, but I don't need to cut less. Now I just need to mark where the holes are. We'll align it on the left side. Okay, marker. Here. This is hole 1. This pin. This is hole 2. Here, sadly, it's not in a hole. It's hole 3. Here is hole 4. Up. Let's remove this while we're cutting it. I did have a board to cut things on. Where is it? Yep. Let's use this so I can pierce it through. So these boards I don't need anymore. Put them here on the side. Don't need the cutter for now, which we never know. So let's put it on the side. Breadboard, that's done. Your job is completed. This, put it on the side with the other board. What size is the hole? I would say 2 millimeter. Let's check it out. That's 3. This is, I don't know, but it's the correct size. So we will use this drill. 3 millimeter. So all the rests. And since we're working with power tools, we don't need the gloves, these gloves anymore. Yeah, they did their job. They're already pierced. It's so sweaty inside. And we will use proper gloves. I should have a pair here. Yeah. Thick gloves which are made for not pinching your hands. I think it's these are, don't know what the actual type of gloves they are. There's some kind of norm for it, but for some working it's nice they add some bit of protection. So let's mark the holes. This will Ideally, I would have self-tapper screws for here. I'm not sure if I do have 2mm self-tapper screws. Up the 4 holes. Does it fit? 1, 2. Not completely. On the side, they are not aligned correctly. Up. Now I've got 2 holes, and it's between the 2 holes, but the screws will hold on the side, and the most important is it holds it down. So we'll just use 2mm. Let me check if I have self-tapping screws. I don't think I have that small self-tapping screws. Up. Here's my screw box. Up. M3, but we want M2. Plenty of M3. Do I have metal M2? M2.5 nylon, M3, M2 screws metal. I do have. They're not self-tapping screws, but at least I have 4 of them. I don't think I have this. I think the minimum I have here are M3s. So, M2. Oh no, they won't. No, not self-tapping enough. It will not hold. So let's check inside this box if we find M2 screws. Let's say here. These are even M1 screws. Not here. I need a screw set, but I don't do a lot of metal work, things like that. This is why it's not too important for me currently to have a screw set. Where is the board? Now it's getting crowded here, and I lose the overview. Here. Perfect. These would be nice. I have 1 of the screws. I just need 3 more. 2. So these are self-tapping screws. They fit the hole. That's too large. Probably. Oh. Are they not too large? No, should be fine. 3. Too long. Here I see 1. And 4. They don't look all the same, but they should do the job, and we'll try them out. Screwdriver. Here. First one fits in. Nice and tight. one too. They don't look all the same from the top, so it looks like a cheap product where you didn't have the same screws and you just took whatever was lying there, which I hate in professional products, but hey, 4 screws they're holding inside. And they will also fit in here and screw on this board. So this will be held together. Now let's get rid of the screws. Up, screws gone. This don't need anymore. It's over here. Power tool probably don't need anymore. We don't need the standoffs because we will use screws. Okay. Here's the board. Now we can start soldering things on it. Up. Soldering iron. Let's start. Up. That's the maximum in the front. I don't need to forget to add a header here so we can plug. I had a 1 pin. That's it. Stick. I need to buy some headers soon. Running out of it. Headers. Sorry, iron should be warm. This camera does a lot faster to focus. It's nice. So let's tuck it in one corner. Reheat it, press on the other side to be sure it is well on the bottom, and do the same for this side. Tack it up. It's holding well. Now we can solder everything. Ideally, you would alternate the pins. You would alternate which side you are soldering on. This allows you to let it cool and spread the heat across the whole board. And not stress the components. But yeah, do it fast enough. And it's not that sensitive. We don't have so many sensitive parts. We want the fillet to be on all sides. Come on. Okay. And this is lead-based solder. It's easier to solder and it's easier to see if the finish is good. Just need to wash your hands, although now I don't. But if you don't have any gloves, just need to wash your hands afterwards and don't lick your fingers. This way you don't have any blood poisoning due to lead, and you don't get stupid. Up. This is soldered. We can put this inside the box so we don't lose it. We need to solder the header. The pinout is written just next to it, so there's nothing I need to do there. Nothing I need to write. Solder one pin, wait when it cools, reheat the pin so I can press it so it fits correctly. And then when it cools, we can solder the other pins. Up. 4 pins soldered on, 3 to 3 volt ground, TX, RX, and we need to make bridges. All these 4 pins. One, two, three, four. We have solder bridges. We've connected the pins correctly. Now, this thing, we'll put it on the left because we still need some space to put this device. If we put this device, we don't have access to this screw. Although we do have access to the screws through the fins. Yeah, not ideal, but this will be the way. Can we do it this way? That's better this way, still. So, let's put it. Actually, I can't. That's the furthest I can. Tack. Yeah, there's enough space for the screw. Let's remove the screws. Should be enough space for it. Yeah. Let's remove the screws. 1. 3. And 4. The camera, I'm just looking at now. We could shift a bit the camera this way, so you can see it better at the edge. Oh, will be tight for the cables. Really tight. Here the power cable is coming in, so it will be held here, and then we have single wires coming. It's not ideal. Can I put it? We've tested that we cannot put it this way. Could add it on the side. Does it fit on the side? No, it doesn't. If we had the brick here, we don't have access to the screws. So yeah, we have to put it here, and then the cables really need to sneak through on the side. That's how it is. I think that's good enough. solder the power brick. Dun, dun, dun. Power brick is soldered. Yeah, that will be the input. It will be tight, but I think we can get the cables here. We do have some lenience. And then we need to somehow have them soldered on the bottom. Yeah, doable. We have no choice. Something is the way of the... What is... this pin. The pin is touching this. I need to cut these pins. Is it something important? Yeah, it's VN. Obviously it's something important. But else I'm not in front of the screws. Why does it have to be so complicated? I can try to melt this plastic or to cut this plastic. Let's try that. Without breaking the case. Up. Now it's not in the way anymore. Now it's gone. Ah, better. Fits again. Next thing, we need to connect this. There we need to make holes again. Mark where I need to make holes. This line, this pin, this pin, this pin. We need 2mm holes. This won't be in the way. Up. Not sure if there's any copper to solder on anymore. But there's on one side. See, we've drilled completely the copper away, so we won't be able to solder on the copper. But we don't need to. We need to solder directly on these pins. So let's solder these pins. Solder. Yeah, no point in putting any solder on there to hold it. But the 4 points on here should be fine. Ah, I didn't count. Damn it. I have to move it because it fits in height, that's not an issue, but I don't have enough space for the connector. So I need to put the thing somewhere else. So let's use our desoldering gun, because desoldering this is not a lot of fun, but without a desoldering gun and with the desoldering gun it's a lot easier. But it needs to warm up and this takes a bit of time. The LED. There's the marking. Where is the LED? This is the resistor for the LED, but I don't see the LED anymore. It should be somewhere around here. Damn it. The LED is missing. Is it inside here? No, here is the LED. The LED will be here. Can put this lead here. Up, that's an RGB LED. We'll just have one source. One. Okay, while this is now it's the desoldering gun is warm. Up. Was that something fell? Just the hot air station. And almost done. Is this enough? Let's test it. Let's solder the LED while we're at it. I desoldered. Let's snip the leads while holding them so they don't. Although could bend them so I can solder the leads on the corresponding pins. 1, 2. Put it the other way around. 3. Now we can try to solder. We have to make a hole. This way. Try to have it kind of straight. Up. straighten off. I can switch off the heating gun because this works well. Up. And the desoldering gun makes really a lot of noise. And it won't cool off so fast, so if you really need it again, it shouldn't take too long to switch on and get to temperature. 1, 2. So this is a common anode LED. The common anode will be through the one single resistor, because we need just to enable one LED at a time. We don't need 3 LEDs, so sharing the resistor is fine. Up. Makes the circuit smaller. So we do 3 volts. This is 3 volt outputs. Here. After I go to the LED. Here go to the 3 volts. Up. Cut the leads. Here I don't need to hold the leads because on these resistors the leads are really soft. There's no way they can jump anywhere. That's the thing. Now, if we put it, do we have enough space for? Let's put the seconds. So this goes here. This goes here. I think these are where I found these cases. I think it was for originally for Sonoff modules. Up. Just put a Sonoff here, so you have a. Whoop. What is going on? Should be the same. M12, yeah. Please, please, please fit. Yes. It fits. So here the cable have barely a chance, but we only have 2 small cables, and the small cable can go past here. We just need to be. So this is input. No, we have 5 cables going out. Right. This is the input with the 3 cables. This is the output with the 5 cable. Well, there is one output with 3 cables and one with 2 cable. Goes one for the tachometer and one for the power. So it will be tight in there, but I think the cables can go through. To these connectors. We said we want to use this, so we will have it on this side. Shall we do the cables now? Or shall we continue solder the components? Let's try with the cables before we continue with the components, so we see if everything fits nicely. So we need a power cable. Mains cable, not power cable. Mains cable here. Mains cable with mains cable. All of them don't have earth. I need earth. Oh. Don't have any cable with earth. I need one with earth because I want to earth the motor. Our box doesn't need to be earthed, but the motor does need to be. Oh, by far most which I have don't have earth on them. Okay, I do have a last one with Earth. Else I need just to cut a cable, but it would be a shame to cut a cable just for that. I do have one. It's there to be used. Up, so we use this connection. There's already cut on one side. It's a bit no, it's not too short. That's okay. And here we have Earth. One European plug. And Earth can directly go from here out here. We don't need any Earth in here. So these are the connectors. These are also Vivo connectors, which I think, or Vivo clone connectors. I don't know. This is advantage because you can directly connect on the other side the thing which you want to connect to. But I don't have a lot of mains cables left over with Earth on it. That's a shame. Do I have access to the mounting holes? Yes. I need to shorten it, I think. Do these things have 3 connections? No, they only have 2. This one has 3 connections, but it's a bit too small. This one has 3 connections. I just think I will use this. This will be the output. So let's never forget to put these things. Oh, doesn't fit. Ah, it does. Okay. Will be very tight though. That's good. It means that the sealing will be even better. Now, up, we don't want too much in, because we want to have the cables flexible on this side. Okay, now just here they're flexible. Okay, and by tightening this up, should hold really well. And up should be protected any ingress. And if I have the pull test, it holds. You really need to pull strongly to get anything out. So that holds well. Let's put the board back in and see if we can fit, if the cables can fit. So Earth can go on this side. 2 other things. Neutral, we need 1 neutral. It's not easy to put in. But not easy doesn't mean impossible. They fit. And they hold well. So, can also put the other cable on. The other cable will be a bit harder, but we have to do it. This cable seems to be a bit Yes, it's getting in there without any issue. But this means that that's not, once you tighten it will hold together. If I put it, no, I can't put ones on the back because the heatsink is on the way. Let's up. Let's strip the cable. Stripping tools. Up. You. I have plenty of stripping wire. Up. That's not long enough, and I've got the earth. Didn't put too much attention to it on it. This is really thin wire, but that should be enough. Yeah, it's not very thick compared to this. This is very thin, but we don't need a lot of current. It should be good enough. What's the rating on this cable? Power cable 0.5 square millimeter. I think it's enough for our motor. Again? Well, having exposed earth is not too much of a problem because this is protective earth. But I didn't expect that it cut the. Was it just really fragile? Didn't expect that the earth is cut twice. Or we can use this side on the crimp now. Let's try again, just having a bit of earth not cut. Just a tiny bit. Okay, a tiny bit of earth. So that's the one connector, one connection which goes inside here. So let's remove the board. Can I close it? I didn't check because it goes a bit higher. The board goes a bit higher now. Can I close it? Wire, go in. Yes, I can. It's really tight, but it closes. Won't get any heat dissipation through the air. It's not a problem. So, board, you come out. Where's my spatula? Yeah. It is tight. But it just means that it holds better, doesn't it? Cable gland. I forgot this one. Hup. Yup. That's the first cable. Now we need some kind of other cable. Not too thick because it still needs to fit inside here. USB cable, something like this. This is normally USB power cable, but it's thin enough. probably to fit inside. Yeah, there's only 2 cores inside. We only need 2 cores. Let's see if we can fit it in. Ideally, it would be a bit to have something which is a bit flat, so it fits better inside. Yes, this is flat, and this has only 2. This is better. This is probably from a telephone line with 2 conductors only. But the advantage is that it is flat, and when it's flat, it fits better inside here, and the seal will be better. Up. I forgot. To put it through this wire, through this cleanse. Oh, it barely fits. Up. With a bit of force it does though. Oh, maybe I need to put in the internal resistor. So the problem now is that I'm probably strong enough. Yeah, that's strong enough. The problem is that we have a line next to the power line, and this could be cross-talking, but I'm pretty sure that the motor is strong enough and the tachometer to not have this issue. Okay. Cables are in. Let's try to close it. Up. This is very tight. Yeah, no water is going in here. Nothing is coming out. Again, and the board will make it fit, because we need to. So let's start soldering the cables. The cables will come from this. So earth can be directly connected from one to the other. Directly soldered from one to the other. We can cut it. Check. Up. This will be earth. I'll have a bit of a leeway. So we can bend it like this. Get it around here. Up. I've got some of the cores, but not too dramatic compared to the other. Let's try if we can. I'm more afraid not being able to solder this cheap copper. Oh, it's okay. It's doable. Let's pre-tin also this side. Up. There will be a fuse. We need a fuse. Do we add a fuse holder? I'll probably add a fuse holder. But first, up some shrink tube. Is this large enough? Yes, but not for the, it's large enough for the core, but it's not large enough for the cable. This should be large enough for the core and the cable. Up. Yes. It's too long, we only need this piece. We will keep the rest. Up. We should add on the other side, because this is the one which will get bent. It's so rigid. So let's add a lot of solder on the tip, and the flex should hold long enough so I can solder the cable together. It's ugly. It's really ugly. Better. A lot better. Now let's hope the shrink tube didn't shrink too much so I can fit it. Yes, I can. And let's use a heating station, 200 degrees Celsius, and with hot air. And just finish a shrink tube up. That's done. Hot air gone. One cable. Now we will add a fuse, and for fuse I do have something special. I think it's in power protection. Power protection. No, it's not in power protection. I mean, one part is in power protection, but the other part is somewhere else. I think I've named it fuse holder, but I don't see it anymore. So many boxes. Temperature, quick tests. Not here, not here. IDC cables. Where are the fuse holders? Here, fuse holder. It was on one of the boxes which are outside. We will use something like this. And inside here, you can put one of the glass fuses. And we will add glass. Oh, one fuse, but we will add a glass fuse. It's not a high rupture fuse, but seriously, we don't care because it's in a protection case. Glass fuse. Here I have a box with glass fuses, and we will use something small, something with 0.5 ampere. 0.5 ampere means we have 100 watts. 100 watt might be not enough. Let's start with 1 ampere. 1 ampere should be plenty sufficient. If it's not enough, I can measure in the end. Yeah, I would measure. So let's start with something large, like 1.6 ampere. And if this works, we will decrease it. But for now, we will use add. Yeah, we can put one of these fuses. Oh, these are spring-loaded. So these contacts here, as you can see that they have springs inside. So they're spring-loaded and they make really good contact with the fuse. Up. So then you have a glass fuse here. I think this is also from automotive. Really useful. The fuse. Do we add it on the neutral or do we add it on the phase? I think it's not important, but we still have to make the decision. I don't know if there's any norm or something like that defining where the fuse should be added. In power boxes, it's always to the phase that it's added. So we'll add it to the phase, and the neutral is kind of unprotected, not completely, at least on the RCD. No, the RCD also there is something like that. But this is where it's measured on the phase. So we will also add it on our phase. We can shorten it, but we don't need to shorten it because do we have enough space? We don't have a lot of space. We need to shorten it on one side, and then the cable goes. Oh, we can do it here. And then the cable can go back inside here. So cut the wire. Don't forget that we need to spin the side, add a bit more wire. I'll probably have enough space for everything. Up. I don't know what the regulations are also for soldering main wires. Can you solder? Do you crimp? I don't really know. I mean, in the end, the plugs receptacles are soldered on the board. So at some point there is solder. I don't know what the regulations are. I try to make the safest thing, and I'm sure it is safer than a lot of things which you plug in, starting with tons of wall chargers coming straight out of China, which most of the time don't have any serious protection, but are still plugged in. So tin the wire, that's the phase, and also, yeah, theoretically that's the phase, but the plug can be plugged either way around, so we don't, in the end, we don't know if it's the phase of the neutral. That's one of the things I don't like with the European plug. At least, so the European plug, there are several things. There is the German plug, there is the French plug, there's plenty of other plugs. When the thing in the hole here, this is from the French side, I think, yeah. And on the German side, you have the two things. The earth is on the sides. On the French side, the earth is in the middle pin. And this European connector just fits both of them. And I'm sure there are even more variations. That's the two big variations. I like somehow the one with the middle, because then you have, there is, when you plug it, then you are sure that the left side is connected to the left. So this will be the phase or the neutral. I think left is the phase and right is neutral. So this helps. If you only have the things on the side, you can plug it either way. So phase and neutral could be reversed. It's not too much of a problem, but I still like to have something which is ordered neatly. And I like the UK. I think the UK plug is the best out of all, because you can add a fuse in the plug. They are really flat, and they have this marking. They have this polarity, and thanks to the polarity, you are always sure that one side is phase and the other is neutral. If there would be one plug in the world, from my point of view, it would be the UK plug. I like the power strip also, they're small. So, that's the beginning. I can start now soldering everything in, out, neutral, and out. I hope we can still fit it in. Well, we will. We will just force it in the end, probably. We have, and on this side, actually, ideally we would add it. Well, there's enough space here. We will add the optocoupler, the diode, and the potentiometer on this side, because we will only use pin on this side. Theoretically, we could also do it on this side, though. We have space here. Either way. First, we will try to solder the wires. And I can reuse this wire, since I'll cut it. I can reuse it to mark it, and as I can reuse this wire for in and outs. Although I could, for in and out, I will solder directly these wires. This goes here. And I'll put a leeway so we can still fiddle around with the cables. Up. Check. Back. It's far too long, but at least it allows me to tin the wires, and then we can still shorten them. Up. up, shortened. Now we have neutral in, out. Neutral is this one, and we also add to solder this neutral, and the neutrals will also be here. Plenty of neutrals. The neutral will come from the side. Here there's enough space for this. Up. I do have another pair of cutters which are probably more appropriate, because this goes only up to AVG 20, this goes to AVG 10, which is a big hole. So we will use this wire cutter, it's a lot more appropriate. So the power will come from here. There will be the fuse which goes here and then here, then there will be this thing. Also, I don't know. Yeah, the grip positions would be good enough, and we also have several things. Don't know on mains wire if it's really compatible with these proto boards, or if it can spring from one hole to the other. I don't expect it to go from here and then here and then here, but it would have to arc over plenty of wires. But it could be possible. This is not well tinned. Neutral is connected. Let's clean it a bit. Still to reconnect neutral, still need to reconnect from here to here. So neutral in, out. What's the right? 6 AVG 16? Yeah, 16. This is AVG 16. Pre-tin the cable, so it's easier to solder. We will add also glue afterwards. So even if the cable get loose, or if the solder get loose, the glue should hold it together. Once it works, though, since we're here to have an eye on it if it doesn't work. Up, this is done. One, and I'm sure if I solder the other one, the first one will just will vanish. That's not a good solder point. Solder it correctly. This is a good solder point. When I tug on it, nothing happens. and this goes somewhere here. Tip. I said 1.6, that's this one. Up. Thin the wire. Up. Put the wire on. Now I can also try to improve this other point. Yeah, it's improved. Now we have neutral, and the neutral should also, so this cable will get through the corner here. This will be tight, and the neutral should also arrive here. This will arrive from this side, so let's solder it this way. Up, all neutral connected. Now we can connect the phase, which goes through this fuse, and this also protects our board. So the phase will go here, then from here to here. This is the input, and this is the output. Have plenty of space. Would be nice to be able to have the cable. There is a bit of space, so I can make it go around here up to here. I think this will all do. Let's first solder this one without trying to melt the other one. Still keep the distance. Nicely soldered. Let's trim it so we still keep the distance between live and neutral. So there's plenty of distance. What I could do to protect these pins from arcing over is just drill the holes all around. So even if it arcs above one, it doesn't arc above the other. Oh, we can do that on these pins, but I think it's fine with the proto board. I don't think it arcs over so many. There's no reason for it to arc between all the pins, so many pins. Let's have this connected here. Up. So 16. Perfect. AVG 16. That's 1.3 millimeters. Tin it. Solder it. It's a lot of solder on this tip. This is why I like this tip also. You can put a lot of solder on it, and it holds it quite well. You need to stay there. How does it look? No, it doesn't look solid enough. At least not for me. Probably sure it is solid enough, but I like it even more solid. That's solid enough. Up. Now this wires goes into in. Oh, I have a new subscriber. Plasma bot. Ah, maybe just a bot. I don't mind. Although I don't see the point of having a bot. Could do probably everything without bots. We need a lot more salt on this pin. Just want to monitor. Okay, second one. And the output is this thing. So let's connect the outputs, and then we should have at least the AC side finished. Okay, there's more solder. That's the output, and the thin wire actually helps creating kind of a fuse. So it's not bad. Oh. Luckily I can open this because this needs to go out this way. Hup. Hup. So that everything closes, but before we do that, we still need to connect the output of the power, the voltage regulator, to a board. Glue. We wanted to add glue, but only at the complete end. Once we proved it worked, and just before closing the case, we will add glue on all these points to fix it correctly. Oh, I don't like this cable. I don't like how this cable is getting bent. It's getting above. I prefer it to get below this cable. Let's fix it. I don't want it to break, although it is very soft. It has not a lot of chance to break because it is very soft. I still prefer to put it below here to be sure it doesn't break. How late is it? Okay, I still have a bit of time. Before going there, I need to tin it again because the flux has been removed after all this heating and cooling. Now I can. Well, this is weird. What's happening? Okay. The cable was spreading instead of grouping together. That better. This I prefer. And the fuse can be somewhere around. We can still shorten the cable after some point, but I don't think we need to shorten the cable. They're fine like this. So now we need to plug the 5 volts to the 5 volts. This cable and this desk. Look at this desk, it's a mess. It's always like this when I'm doing projects. Luckily, I clean up in the morning normally. So for cables I use this. These are silicon wires, so silicon makes it really flexible. Inside there are enough cords. This is AVG30, you have it on several other wire gauges. And yeah, it's really flexible. The silicon also helps when you solder because it doesn't melt when you solder. The silicon holds pretty well the temperature instead of PVC, so I recommend this kind of cables. What is plus, what is minus? This is plus. So let's solder this wire on plus. Let's tin it first. Plus, and the plus goes up to this point. This side, the plus goes this one, just leave a bit of margin. We need the plus afterwards for the 3 volts for the how's it called, the triac. On the other cable we still have the end, so there's no loose wire, so I mean this one, so there's no loose wire. This goes here. Five volts soldered on. Here is the hole for the screw. Actually I soldered it the wrong way around because these markings aren't, it's not too important. And then we have minus. Let's do the same thing. Black wire. Pre-tin it. This is ground. Is it? Yes, it is. This goes here. Here, tweezers. All these tweezers have ceramic tips, tips, don't know. Ceramic tweezers, and they come from the e-cigarette market where you need to hold very warm things to change the tips. So the ceramic things protect you from the warmth, and they're nice. So I can hold it for soldering, and if I come with the solder here, I don't damage them. This is why I use them. So actually we have everything for power. So we can try to plug the power and see if this LED comes on. Well, this one and this one. So let's test it. Let's switch on the isolation transformer, although we can plug it actually directly from the other thing. We'll try with the isolation transformer. Ooh, blue light. Blue light means I received some data, but it didn't in the beginning. That's weird. But green light means it is ready. So we do have power coming in, and it did make poof. We are using 1 watt. That's fine. This works. 1.5 watts. That's good news. We're making progress. The only thing which is not connected is this thing, which will be a pain, but we will manage to do it. So, yeah, and we didn't connect this thing. This is what we will do now. We will connect these pins from the track modules up to the board. Let's start with ground because ground is important to start, except in cars. Somehow when you connect the battery of a car, you don't start with ground, you start with plus, and then you connect ground. And why is this? This is because the whole chassis is ground. So if you connect ground first, and then you have a dangling plus wire somewhere around, and the dangling plus wire touches the chassis, then you have a short. And this doesn't happen if you connect first the plus. Then having a dangling ground wire is not important, because the dangling ground wire will only touch the chassis, which is also ground. This is why you connect on a car, you start with plus, but if you pay a bit of attention, it's not really important which one you do, plus, minus. So which ground will we use? Here 3 volts, and then next to it a ground. So this is ground, and we'll use the same 3 volts. Up. This is ground. The ground. Can I read the pins? Yes. Ground, VCC, 0 crossing, PVM. That's ground. Actually, normally I connect the wire at the end. So I should first solder the components. That makes more sense. Let's finish just this wire, and before we do the other wires, let's connect the other components. Let's solder the other components. There are only 3 of them. Yes, we can add it to, although no, there's no side, A0, but it's analog. All the digital are on this side. Man. Okay, good to know. If we do it this way, we need inputs, outputs, yeah. This will be the inputs. Now I decided to put it on this side instead of this side. We could put it under here, but at least here we see it correctly. And we have enough space on the bottom. This way. Around. No. Like this. This allows me to have the anode right on the transistor and have the outputs somewhere here. properly. This way you can still connect it below. So anode goes to cathode out and goes back to anode. I think this is the right way around. Here is our half bridge. You need to connect to this pin. And with that we have all the connections we need. Up. So. Up. This. We connect. You don't see anything. I also actually don't see anything. Cable entanglement is pretty heavy. This is the cathode. Damn it! This should be the cathode of this damn optocoupler, which just decided that it didn't want to be soldered on and to flee. Oh, actually I soldered it on the wrong thing. Oops. That's why it didn't hold together. This is the output of, one of the three legs of the potentiometer. This is the right output, but it doesn't hold right now because it's not soldered correctly. Optocoupler. Optocoupler. Lead, and then the last lead of the optocoupler. Let's short it even more. Two hours, a bit over 2.5 hours of stream, and I think we had half an hour stream at the beginning. Okay, that connected. Last thing is here. This is connected. This way I will go here. Okay. Oh, we do have some solder which has been not melted. Okay, that's done. So now we can continue soldering all the wires because we have all the components on the board. A trick, because this optocoupler does kind of an electrical isolation, you can actually use your optocoupler for MOSFETs. So the problem in MOSFET, you had kind of two types of MOSFET: N-channel MOSFET, where you switch to ground, and then a P-channel MOSFET, where you really switch to high rail. So it's low side or high side switching. You could use NMOS and PMOS are a bit more expensive, and they're not as common. They're a bit more expensive and they're a bit harder to drive because They switch off when their voltage gauge is high. They switch on when the voltage gauge is low. Speaking simply. So you need to pull down the voltage gauge. So if you want to switch 12 volts, you need to be able to pull down 12 volts. What you can do is trick a bit and use NMOS, but the problem with NMOS on the high side is that you need to be higher than the voltage you need to switch 1.2 volt higher, depending on the gate or the threshold of the gate source. So the trick to be higher is just use optocoupler, and on the one side of the optocoupler you create a new ground, which is the high side of the rail. So on the other side of the optocoupler you have a higher voltage, and this way you can use optocouplers to switch NMOS on high side, which is a nice trick. Did I speak correctly? Oh, there's a trick like this. Yeah, I think, yeah, because whenever you create, yeah, exactly. So you can do that instead of having some other kind of driver. So let's continue. We have ground, VCC. Now VCC for the triac module. I have 1 hour. In 1 hour I have to leave. I hope in 1 hour this will be complete. The bench will be a mess in 1 hour. I won't be able to clean it, but I hope that circuit kind of works and I can test it there. I'm sure it will not be finished. I'm sure it will not be finished installation because I will find other issues. But at least if I can test it, that would be great already. We need to prepare the cables also. These cables I have always issues to crimp these cables or to make them correctly. They're not easy. I don't know why. Well managed to do it though. Maybe because I don't do it often enough. So power goes here and here. Up, you don't see anything, almost nothing, but that's because it's hard with all these wires to see anything. Tweezers allow me to be precise. 3.3 volt VCC. The dimmer module can work with 5 volt and 3.3 volt, and it's mostly important for the optocouplers and to pull up the AC signal. Okay, 3 volt there. Then we have zero crossing. Zero crossing is on which pin? I have to check in my pin definition, which is in the source code. So, source code. That we don't need anymore. My pin definition. Zero crossing is on D1 and the gate is on D2. D1 is the second pin. So we will use blue for the gates. Then it's the gate. No, that's not the gate, that's zero crossing. Yes, zero crossing. This is the second pin is D1. Yeah. Actually, I could switch them. Makes nicer. Yeah, I don't care. I could switch them so it makes nicer signals, but we already, yeah, I shouldn't switch them. So let's put it in D2. Makes nicer wiring. This is also a bit too long. I could shorten it, and I will shorten it so it looks nice. Even if it's at the bottom, nobody will see it does the job. My OCD will be satisfied this way. Tack. Tack. Come on. Okay. You go on BCC. And the PVM will be, let's change again the code also immediately. And we will flash the device before powering it up so we don't have any issues. Shouldn't be too much of a problem, but I will do that. Tinned on one side, up, soldered. Up. The other side. Trim is still working. Up. Dozen into clays, really colorful. Green, blue, red, black. In the right order. And let's change the pins. Up. Up. This is done. Oh, this is getting a bit stressed. We will add glue. Once everything works, we will add glue. And this too, we will add glue. It holds. The last thing missing is the optocoupler. Well, two things missing. So the optocoupler, which one is the collector, which one is the emitter? Optocoupler datasheets. 4 is the emitter, so this will be where pulled up signal is. Oh, 4 is the collector. Yeah, 4 is the collector where signal will be, and 3 is the emitter. 1, 2, 3. 3 is the emitter, 3 should go to ground. Up. Up. Pin 3 should be this one. right afterwards. 1, 2, 3. 3. Collector. No. 3 is emitter. Emitter goes to ground. Ground. 1 second pin. Yeah. Where are my tweezers? Tweezers. I am blind. Can you see where I did put my... What? Here. Front of the screen. Looks ugly. Up. Ground is connected, and then the collector is connected to, I think it's D0. Again, let's go and check the code. We could put it anywhere, but where did I put it? Motor taco pin. It's 0. Pin 0. Oh, so Z. Oh, it's D3. There's nothing on D0. No, I don't have anything on D0. Okay. I don't mind. And we will use green. Why not? I have a choice between green and blue. Let's choose green because we have plenty of blue cables to the neutral. So we have more colors. Blue is out, green is in. And we said D3, this should be D3. This is D3. Nope, not this one, this one. Up. Up. Green is on D3. Above. That's done. And now there's only one thing which we didn't connect, which we didn't solder. It's, if you pay attention, you should know what it is. It's this cable. And this cable will come here. And we don't care about the orientation because this is AC again. And it will be half rectified with the diode. Yep. Oh, that's weird. The cable has some kind of nylon. Oh. And no copper. I need metal, else there's nothing I can solder. Okay, here's the metal. Let's burn the nylon. I don't know why they put nylon inside. To strengthen the cable? I have no idea. It's really getting crowded in here. On the bench. Oh, it is holding. But it's not very clean. Let's clean a bit so we can tug on the cable so I can use it right-handed. Let's put the cable correctly inside. Okay, it's not correctly inside. It's gone. Okay. This is weird cable. Breaks easily. This is really weird. Don't know what kind of cable this is. If it doesn't work with sheets, we solder it from this side. This is what I will do. It's really weird cable. Nylon and easily breakable. Okay, let's hope it doesn't break. So we will put some glue also. But first thing first, we need to flash it before we can connect it to power. We don't need this anymore, I think. Let's put it somewhere. No, it's not in the way. USB cable. Nothing is connected to mains, even if it's completely isolated. It's better this way. Okay. Upload. 50%. %. Okay, it's uploaded. LED is green. Everything should be working. Now, before we put glue and before we put everything in the case, clean the case. Didn't pay attention that I had a microphone in front of my mouth. This can go here. We will we'll prepare the cable. Yeah. So now we have this. We want live or neutral and so on the cable. Let's cut it up. Let's zoom out to have a larger overview. Let's try out if it works. Up. This time I didn't break. Plus minus. This. This. Don't need ground for now. So that's the outputs. And we can connect the output to the lamp, which is somewhere behind here. That's the lamp. This desk is overcrowded. That's the lamp. We will connecting using crocodile leads. One. And plus. And all plus. There's no plus. Just line on neutral. The other neutral. Now we have this scale in the middle, so they shouldn't touch each other. Now let's connect. Let's switch off first the power. Where is? You stay somewhere safe, somewhere here. Where is the switch? Here's the switch. Let's give me the switch. It is on off. Okay. Let's switch on to test just. This works. Green, it's ready. And if I switch on, we should have some light. And we have some light. Means it works. And I didn't test it, but it's very probably look. Oh, the dimmer makes a lot of noise. I don't know why. Maybe the gate switching is too slow. But the dimmer makes. That's weird. It's not the thing which makes noise, it's the dimmer. The dimmer makes noise. The triac makes noise. I think maybe the gating is not long enough. I'll increase the gating afterwards, but we know everything works. Unplug power. Unplug power. Switch off the soldering iron because I don't want to get burned by accident. Plug in the hot glue and we can glue things together. before we try to fit it in, and I think we will spend the last 30 minutes trying to fit it in. So I have to read how long the gate should be open minimum. Maybe what I will do is open it until the end of the half cycle, or at least a lot longer, and have some kind of better mechanism than having it in an interrupt, in a time interrupt. But maybe I start 2 times the time interrupt, and the second time I just say how long it switches on. Well, we'll check what the solutions are. Now we have to wait for this to complete. What can we do? We can prepare this kind of crimping cables meanwhile. So I have one ends. I think I didn't get the other ends. Here's the other end. Here. Oh. I think this belongs here. This belongs here. So we need red cover. Oh, you don't see anything. I'll put everything here. So we have this on this side, this on this side. We need 4 of these. One. We can only prepare one side. We don't have anything on the other side. So 2, but I still get everything out. So we have everything. Once we go 3, 4, then we need 4 pins. 2 male, 2 female. That's 2 male. Now I need 2 female ones. Are there? Yeah, they are. They exist. Who put everything in a bag? It's not useful. I have no space. Okay, now they're not in the way anymore. Up. 1 female. And 2 females. I can put everything back, although not yet, because I'm sure I won't be able to crimp it correctly. So this needs to be as long. I could put it also a bit longer, but ideally it would be as long as this cable here. So here, drag, somewhere around here. Tack. This is more wire. Let's put it here. We know. Ah, this is weird wire. This is the flexible nylon stuff. Let's see how well it crimps. Once I did already break it. Because it's flat, it's not easy to strip. I do have something which helps stripping flat wire. This wire stripper. Oh yes, does a good job. I don't need to strip a lot. Should be fine. Oh, it does a lot better job than I did with the other thing. Now, what we don't need to forget is putting these things on. And I don't know the direction. I think it's this way. Yeah, I need to solder them. They seem to be very brittle. 1, Cool. What is female, what is male? Seems this is the female parts. Looking at the inside, this is the male parts. Makes click here, so I think it goes this way. Let's try it. Grip. Oh, the hot glue is warm, but we still need to complete this first. Oh, it's out for a lot thicker wire. It's not meant for such thin wires. And the crimping tool I have is probably not large enough for this wire. Luckily I have other crimping tool. This should be sufficient. No. I have the small one here. This is also too large. So they should be fine. Let's try it with this. Perfect, but a bit of solder. Ah, I switched it off. Whoops, sorry for the camera. I'll try to solder it. Come on, soldering iron, get warm. Clean the tip. Okay. This seems fine. But if I don't have thick enough wire for this. Okay. That's the first one. I hope the second one works also. That well. So we used this side. It doesn't look as nice. Probably still nice enough. And I hope it's long enough. Yeah, it doesn't look nice at all. I'll try to fix it. A tiny bit until it cools. Crimp it better. Oh, this way it's nice. Okay. Let's try to put it on. There was also the red thing. I'm sure I had the cape outside. I don't find it anymore. Take another one. I'm sure while cleaning up I'll find this cover, but the cover should be put last probably. So now find out how to insert those. It goes up to here. The cable is not long enough. I need to cut it in the middle. Tiny bit this way. We don't care which is one, which is two actually. Ah, you can see on the sides how they're sliding in. That's a pain. They're really not easy. I like the robustness, but they're really not easy to use. Maybe you just need to have the habit of doing it, and then once you did a couple of hundreds, like I crimped hundreds of cables, probably a lot easier. Yeah, they're not easy. Oh, you're not seeing anything, but you're not missing anything. I'm just struggling putting this thing on. Okay, I've peeled off kind of silicone rubber thing. Let's see if it works better this way. One. Come on. Such a pain. No, this way. Maybe one after the other, but I need to strip them really long. Again, this way. I really don't have the habit of putting these connectors. I'm not sure if I will use them ever again. Fuck. They're really not the most easiest, friendliest cables I've seen. Because also I don't have the right gauge and I cannot push them inside correctly. That might also be the case. One. Ah, I had one in, not the other. Ah, let's put it one after the other. This is getting too painful, and let's remove these gloves. I don't know. I'll use the gloves soon, so let's not remove the gloves. Try just one. Okay. Ah, you put them this way. Okay, always I did put them the wrong way around. This way seems a lot easier. Almost there. I have something to push it in. One, two. Looks okay. Let's put the guard on it. Not even able to push the guard on top of it. I only have this one, right? Yes, we only have this one. Come on, get in. Why don't you slide in? Okay. Whew. 10 minutes of pain. This is the first connector. I hope this is robust enough on this cable. Yeah, I think it's robust enough. Whew, this was a pain. So now we just need to keep the other side in our box with the crimp, and now let's glue everything together. So everything which is high voltage will get glued. Actually, there's not enough space anymore. This should go this way. Come on. Don't run away. Stay here. I don't have enough space on my workbench to even put the glue gun. Now I have glue. Not glue there. This is also high voltage. This gets covered. Not taking a risk here. Okay, now we need to wait 5 minutes till it solidifies. Here there's still potential contact from the outside. Here, no, there's not anymore. Remove the glues from our fingers. Up. That's done. And now, once it's cool, we will try to box it in. And meanwhile, while it is cooling, let's do the other side of the cable, this side. And we'll have as much pain on this side. This is female, this is probably male. So, this for both sides? Yeah. Do I have enough of these yellow things? So we need one of these. Let's put it in this box. One of these. And I think this one is the one I need for mine. 1, 2 male, 1, 2 female, 3 male. That's male. So female. Then we need all these yellow wires. Here's the protection. See, I remember I had it. We need 1, 2 protection on the other side. So this goes to the other box. Where is, yeah. This goes in here. We can put these back in. This one also, don't use it anymore. Back, up, and now 6 of these yellow thingies. 1, 2, 3. The 3 males go in the box. 1, 2, 3. 1, 2, and no, 2. The yellow thing. 3. This one I get to use. This is the female part, as we did from this side. Yep. This is not long enough. So, is it? Up to here? No, that's not long enough. Not the right one. Here's the side cutter, the stripper up. So we strip a bit more this cable. Or it is, although it is cool now, we could try to put it in. Let's just strip this cable, then we try to put the board in. Up, cable stripped. Cable stripped. Hardest part now, putting the board in. This goes to the side. It is in. And I would never, I don't need even, damn it. One of the cables got under the screw, but it is. So the fuse is fine. I have it this way. I cannot put it completely on the ground because there's... Oh! Damn it. I cannot close the box anymore. There are a couple of millimeters missing. Oh shit, and now I broke the box. The problem is that put the glue... I have to get rid of it. Still hope it's watertight. Okay. There is one problem here. Let's get this come out again. Oh, I broke the reset button. It's super tight. Don't need any screws for that. But the problem is I still need to lift it because... okay. Just had to do it gently. The issue is... I'll remove 2 of these things. The issue is this one, which blocks, which holds, which gets against the glue. and because of that I cannot put the board correctly inside, so we'll have to cut, and I'll cut also this one. It's not in the way, and this one. Now we should be able to put the board in. Ideally these should come from the side. Now it's inside. I still have damn cable, power cable, but can I close it now? Yeah, the heatsink. Heatsink is a tiny bit on the way, but I can close it. This heatsink is on the way, in the path. I can bend it a bit, and I can close it. The reset button is gone. Don't care about the reset button. What would be nice? It holds pretty fine. I'll add one screw. I don't have even access to this screw. I'll add one screw just for the sake of it, but it's impossible to remove anymore. So the one screw will be this one right here. Damn it. I broke the thread of the screw. Even getting a screw inside is a pain. Let's use the proper tool. Okay, this board will not lift. This will stand there forever. Phew. This screw will hold. Oh god, the screw is not up to the bottom. This screw will hold it for sure. Now, I want to try, before I put the cable, I want to try again if it works. So, here we have the lead going through the lamp. I will add a dab of glue also on this connector to relieve any possible stress. So, screw is here. Let's connect to power. Up. The LED should turn green, and if I switch on the light, we have light. This works. Turn this off. I have 10 minutes before I need to go to complete this, and for the last part I need to put the connector on this one. Let's switch the hot glue off. Hot glue is off. Damn it. Got too much of it. Here are the 3 connectors. Again, I don't have the right tool for the job. Doesn't look nice at all. Let's solder the wires. So we should make a good connection. And I did miss something. I did miss putting these things on. I hope I can put it over this, else I'm screwed. As I can. Up. Up. Let's try to kind of improve this very ugly crimp by cutting it away. What's this metal? It's hard to cut. Solder wires. Okay. I've soldered the wire on it. First one. Let's not make the same mistake with the other ones. Put the sleeve on, which is probably just ingress protection. And since we want everything watertight, dust tight, corrosion tight, why not? I'll tin the things first, probably make it easy afterwards. Up. Third sleeve. Now you're not seeing anything I'm doing. Okay. Now I found that this crimping tool with the largest setting is nice to crimp at least the metal part. Yes, perfect for the metal part. Oh yes, for the metal part it's really nice. Let's still solder it. Okay, soldered. And for the large parts, well, I can still crimp it by hand, but I'll try with the largest setting here. This one. It did work nice twice before. it works kind of nice. Not perfect, but it still holds the cable well, and then I can, using normal pliers, regular pliers, can still press it, and it looks okay this way. So you never have enough crimping tools. Almost each connector and each cable needs its crimping tool. Okay, that's crimped really well. This crimping tool is nice. Let's solder the wire. Although when you crimp normally you don't need to solder the wire. I still prefer it, and let's crimp it. Please make as good results as the last one. No, not as good. I can still fix it. No, there's no fixing, there's only cutting. The thing that should hold the wire isn't holding it. Okay. Put it in here. Did I put the wrong side around? I don't remember. We will put ground first. Which side did I put it? As far as I can see, you put it on this side. Ah. Will this work? I'll try. I put always ground in the middle. So if any cables get loose, then it goes to ground. Okay. Contacts ground before it can contact the others. Or it's more likely, at least. Ground is in. Live is in. Well, not completely on the, not completely, but still good enough. I'm not sure I need to bend it tiny bits. Up, else it won't fit. Come on, neutral. The last one. Neutral is in. Now I just need to push them. Up. That's nicely. Inside. Oh. The line. Okay, ground is completely, no, line, the phase is in, on the line, and somehow I don't manage to get the ground completely in, which is the most important, not for working, but for safety. So you go in. Okay, it's in. And now we put the gasket on. And it's on. It's not completely on though. You can see there's a kind of thing on the top, but that's it. It holds really well. Not sure why it doesn't want to clip. It did clip on the side. Maybe once I put the connector on the other side, it will hold a lot better. But that's it. I just need to close the case. And with that, we have the case. And tonight, now, I need to go and test if it works, so I can report next time. And I'm sure there are some things I will need to fix. But for now, let's switch everything off, and the stream is done. Yeah, I'll let you know afterwards with probably a bit of pictures if everything went well. So enjoy after 4 hours and more of stream. Bye.